page 90, and we're going to look at the process of how to simply convert between the mass of a substance and the number of moles present in that substance. So the big idea here is that 1 mole of a substance, when we place it on a digital balance, the mass that's going to read out is going to be equivalent to the GFM of the substance. So in order to do the conversion is always done as dimensional analysis. So let's take a look at this I do. Determine the number of moles in 40.2 grams of carbon monoxide. Well, in order to convert grams to moles, so I have 40.2 grams of carbon monoxide. I'm in grams. I need to get to moles. And when we do dimensional analysis, whatever unit we start off with, we want to be able to reduce it and cross it off. So now I have my relationship here, and this relationship is the GFM, the number of grams in 1 mole of a substance. So in order to have my information, I need to calculate the GFM of CO. So when I go and pull out the periodic table, I have 1 carbon in the formula. It contributes 12.0 grams, plus I have 1 oxygen that contributes 16.0 grams. And when you add those together, they equal 28.0. So 1 mole of CO equals 28.0 grams of CO. So this is the relationship that we use in the fraction in order to convert the number of grams we have in the lab to moles. So 1 mole of carbon monoxide has a mass of 28.0. So when I do this mathematically, and I put this into the calculator, I have 40.2 times 1. That product is then divided by 28. And when I put this in the calculator, I end up with 1.44. But the math I do with the numbers in the calculator, I have to also do that with the units. So I have gram times mole divided by grams. I have a grams upstairs and a grams downstairs, so I'm allowed to cross them off. They reduce to 1. So the grams are no longer present, and my only unit that remains is the mole. So I have 1.44 moles of carbon monoxide. So one of the things that you will need to get used to doing is there's no shortcuts, is you have your calculated quantity, the unit, and the substance it belongs to. So a final answer will have a value, it will have a unit, and it will also contain the identity of the substance. And so this conveys a lot of information. Look at the next example. So in the we do, it says determine the mass of 24.6 moles of carbon dioxide. So now in this problem, I need to go from moles to mass. So I start off with the mole value I'm given, 24.6 moles, and this belongs to a formula of CO2. I'm going to set up my dimensional analysis. What I want to do this time is I'm in the unit of mole, but I want to change that unit and express this quantity in grams. I want to be able to cross off the mole. The relationship grams to mole, mole to gram, this is the GFM relationship. So I need to know the GFM of carbon dioxide. So I'm going to go over here and I'm going to calculate it. So I have 1 carbon, which contributes 12.0 grams, plus, now this is carbon dioxide, so there are 2 oxygens each one contributes a mass of 16. So when I put this into the calculator, 44.0 grams of carbon dioxide are present in 1 mole of carbon dioxide. So like before, this information is the relationship between the mass and moles of carbon dioxide, and this is what I use to put into the dimensional analysis problem. So it's 44.0 grams in every 1 mole of carbon dioxide. So in my calculator, I multiplied the 24.6 times 44.0, and the product is divided by 1. And so as a result, I would record this value as 1080. So 1080, I have to do the same math with the units. I have mole times grams divided by moles. I have a moles upstairs and a moles downstairs, so I'm allowed to cross them off. They reduce. So my unit that remains is the gram. And the only substance present in this mathematical equation is CO2. So I'm labeling. I have 1080 grams of CO2. And so notice in my answer, I have a value, I have my unit, and the identity of the substance that this mass belongs to. You try the 2 you-dos listed below. Check your work with your teacher.